Hi, welcome to Geometry 4.2 Triangle Congruence by side, 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 and side angle, side. Our objective is to prove two triangles are congruent using side, 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 and side angle, side postulates. It's essential that you understand you can prove two triangles are congruent without having to show that all of the corresponding parts are congruent. In this lesson, you will prove triangles congruent by using 1. 3 pairs of corresponding congruent sides, and 2 pairs of corresponding congruent sides and 1 pair of corresponding congruent angles. So we're going to use side, side, side and side angle, side postulates. The first postulate that you want to take notes on is postulate 4.1, side, 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 or SSS postulate. This postulate, it's a rule, remember postulates are rules we accept without proof. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the two triangles are congruent. So we don't have to know anything at all about the angles if we know all of the sides. So if segment AB is congruent to segment DE, segment BC is congruent to segment EF, and segment AC is congruent to segment DF, then we can say these two triangles are congruent using the side, side, side postulate. Pause the video and fill in your note template. Example 1, we're going to write a proof proving two triangles are congruent using side, side, side. We're looking to prove that triangle LMN is congruent to triangle NPL. We're given that segment LM is congruent to segment NP, and we're also given that segment LP is congruent to segment NM. So this is what we're given, that LM is congruent to NP, and also that LP is congruent to NM. Can we prove that third side is congruent? Each of these triangles contains this side, NL or LN. Is this side congruent? Using reflexive property of congruence, we can say that NL is congruent to LN. So LN is congruent to NL. Using the reflexive property of congruence, and something's congruent to itself, it's the same line segment, just it's included in both triangles. It's in this triangle, LMN, and also in this triangle, NPL. So therefore, it's congruent to itself. Now that we've just proved that all of the corresponding sides are congruent, we can say that these two triangles are congruent using the side, side, side triangle congruence postulate. So we can say triangle LMN is congruent to triangle NPL using SSS. SSS stands for side, side, side triangle congruence postulate. The word included refers to the angle that comes between two sides and the side that comes between two angles. If you look here, angle A is included between these sides. So angle A is included between sides BA and AC. Angle A is included between them. Segment BC is included between angle B and angle C. BC is included between them. You'll notice when it's a side that the segment's name is the letter of the two angles that it's included between. And when it's an angle, then the name of the angle is the letter that both of the segments have in common. And that's how you'll know it's included between them. So included. This is important because now we're going to talk about an angle that's included between two sides. The side angle side triangle congruence postulate, or SAS, says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So if in this triangle AB is congruent to DE, so that's a pair of sides, angle A is congruent to angle D, so that's an angle. And then finally, segment AC is congruent to segment DF. That's another side. So you see how we have side, angle, side. Then we can prove these two triangles are congruent. Triangle ABC is congruent to triangle DEF using the side, angle, side congruence postulate. Pause the video and take notes. So example 2 is proving triangles are congruent using side, angle, side. We're given here that segment ZW is congruent to segment XW. So ZW and XW, those are sides. We're also given that segment VW is congruent to segment YX. Sorry, that should be YW as it's clearly marked in the picture. Little typo on your notes. Can you fix that? And so these are also sides. So we have two pairs of sides that are congruent in these two triangles. What do you know about angle ZWV and angle XWY? They're vertical angles, so they are congruent. So we can prove that triangle VWZ is congruent to triangle YWX using side, angle, side. Because we have a pair of corresponding sides, an included angle, and another pair of corresponding sides. So we have side, angle, side. So let's write the proof. We'll begin with what we were given. Remember to change that YX on your note template to a YW, as it's clearly marked in the picture, YW. So your proof should look like this. Segment ZW is congruent to segment XW. That was given to us. ZW is congruent to XW. Then we said that angle ZWV was congruent to angle XWY by the vertical angle theorem. And then we were given that VW was congruent to YW. And therefore we can prove these two triangles are congruent because we have side, angle, side, two corresponding congruent sides, and the included angle, the angle that comes between them. So let's take a look at these pairs of triangles and see if we can use side, 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 angle, side, or is there not enough information to prove that these two triangles are congruent. So look at example A. Are these two triangles congruent? What do you think? We have one pair of corresponding congruent sides are congruent. Then we have here that AD is congruent to CD. And what do you know about this side that they share? When they share a side, then it is congruent to itself by reflexive property. So these two triangles are congruent using side, side, side. Let's take a look at B. We're given here that this side is congruent to this side and that this side is congruent to this side. Well, we're given two sides, but we're also given something else. These arrows, remember, they indicate that these two lines are parallel. And so they are parallel lines cut by a transversal. And therefore, what do you know about this angle and this angle? They are, if you turn your paper, you'll see it more clearly, corresponding angles. And because they're corresponding angles, they're congruent to one another. And so, using corresponding angles, we can say we know that these two triangles are congruent because we have side, angle, side. So using the side, angle, side congruence postulate, these two triangles are congruent. Let's take a look at C. For C, we know this. EF is congruent to GF. We also know that this angle, EHF, is a right angle. So that means that this segment is perpendicular. So GHF is also a right angle. And then they share this side. So because they share that side, remember that's using reflexive property. Well, what do we have here? Do we have enough information to prove these two triangles are congruent? We have a side, another side, and an angle. Do we have the included angle? We don't. You have to go in order when you are reading triangle congruence. You can't skip over more than one thing. So in this case, if we look at just this triangle, EFH, we have side, side, angle, because you have to go like this. We can skip over an angle, but you can't go this way. You can't go side, skip an angle, skip a side to another angle to a side. You can't do that. You can only skip over one thing, either an angle or a side, when you're reading these. So we have side, side, angle. And on this triangle, GHF, we have angle, side, side. That's a swear. You can't have that. There's no swearing in geometry. You can only have side, 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 or side, angle, side. If we knew that this angle was congruent to this angle, so that would be the included, then we could prove it. But in this case, we don't have enough information. So we can't prove these two triangles are congruent. So not enough info here. Not enough info to prove that these two triangles are congruent. Let's take a look at this last one. We know that this pair of corresponding sides is congruent, and we know this angle is congruent. And then finally we have this shared side, and when they share a side, by reflexive property you can prove that it is congruent. And therefore we have side, angle, side. So because we have side, angle, side, side, angle, side, we can prove these two triangles are congruent using side, angle, side. You wouldn't go the other way. You wouldn't say side, skip this, go here, side, angle. You wouldn't do that. You can only skip over one thing. So when you're reading these triangle congruences, you want to go in the direction of the next closest congruence. So in this case, I want to go this way. Side, angle, side, side, angle, side. So because we have two pairs of corresponding congruent sides and the included angle, the angle that's in between the two sides, then you can use side, angle, side congruence. Go back and review over any of these or take any notes that you need to. Make sure tomorrow in class you ask questions. We'll work on identifying special angle pairs, pairs of congruent triangles, when you can identify them using side, 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 and side, angle, side.